Welcome back. Let's read some more. Try to make some Danish video about old jet engines. It was supposed to be in English. It's 3 p.m. I start to get tired. So just made a Danish video about this engine. I read about early today. So let's read about this. He made this engine, Power Jets W1. That's the first jet engine in a British trooper engine. He made a company called Power Jets. I read about next. But I need half a minute to get to my bed. And I'm freezing a little bit because it's freezing cold outside.
Frank Whittle. Air Commodore Sir Frank Whittle, OM, KBE, CB, FRS, phrase, the 1st of June, 1907 the 8th of August, 1996, was an English engineer, inventor and Royal Air Force, RAF, air officer. He is credited with co-creating the turbojet engine. A patent was submitted by Maxime Guillaume in 1921 for a similar invention which was technically unfeasible at the time. Whittle's jet engines were developed some years earlier than those of Germany's Hans von Ahn, who designed the first to-fly turbojet engine, as well as Austria's Anselm Franz. Whittle demonstrated an aptitude for engineering and an interest in flying from an early age. At first he was turned down by the RAF, but, determined to join the force, he overcame his physical limitations and was accepted and sent to No. 2 School of Technical Training to join No. 1 Squadron of Cranwell aircraft apprentices. He was taught the theory of aircraft engines and gained practical experience. Frank Whittle. Air Commodore Sir Frank Whittle, OM, KBE, CB, FRS, phrase, the 1st of June, 1907 the 8th of August, 1996, was an English engineer, inventor and Royal Air Force, RAF, air officer. He is credited with co-creating the turbojet engine. A patent was submitted by Maxime Guillaume in 1921 for a similar invention which was technically unfeasible at the time. Whittle's jet engines were developed some years earlier than those of Germany's Hans von Ahn, who designed the first to-fly turbojet engine, as well as Austria's Anselm Franz. Whittle demonstrated an aptitude for engineering and an interest in flying from an early age. At first he was turned down by the RAF, but, determined to join the force, he overcame his physical limitations and was accepted and sent to No. 2 School of Technical Training to join No. 1 Squadron of Cranwell aircraft apprentices. He was taught the theory of aircraft engines and gained practical experience in the engineering workshops. His academic and practical abilities as an aircraft apprentice earned him a place on the officer training course at Cranwell. He excelled in his studies and became an accomplished pilot. While writing his thesis, he formulated the fundamental concepts that led to the creation of the turbojet engine, taking out a patent on his design in 1930. His performance on an officer's engineering course earned him a place on a further course at Peterhouse, Cambridge, where he graduated with a first. Without Air Ministry support, he and two retired RAF servicemen formed Power Jets Limited to build his engine with assistance from the firm of British Thomson Houston. Despite limited funding, a prototype was created, which first ran in 1937. Official interest was forthcoming following this success, with contracts being placed to develop further engines. But the continuing stress seriously affected Whittle's health, eventually resulting in a nervous breakdown in 1940. In 1944, when Power Jets was nationalized, he again suffered a nervous breakdown, and resigned from the board in 1946. In 1948, Whittle retired from the IAF and received a knighthood. He joined Bork as a technical advisor before working as an engineering specialist with Shell, followed by a position with Bristol Aero Engines. After emigrating to the US in 1976, he accepted the position of Naval Research Professor at the United States Naval Academy from 1977 to 1979. In August 1996, Whittle died of lung cancer at his home in Columbia, Maryland. In 2002, Whittle was ranked number 42 in the BBC poll of the 100 Greatest Britons. Early life, edit. Whittle was born in a terraced house in Newcombe Road, Earlston, Coventry, England, on the 1st of June, 1907, the eldest son of Moses Whittle and Sarah Alice Garlick. When he was 9 years old, the family moved to the nearby town of Royal Leamington Spa, where his father, a highly inventive practical engineer and mechanic, purchased the Leamington Valve and Piston Ring Company, which comprised a few lathes and other tools and a single-cylinder gas engine, on which Whittle became an expert. Whittle developed a rebellious and adventurous streak, together with an early interest in aviation. After 2 years attending Milverton School, Whittle won a scholarship to a secondary school which in due course became Leamington College for Boys. But when his father's business faltered, there was not enough money to keep him there. He quickly developed practical engineering skills while helping in his father's workshop, and being an enthusiastic reader, spent much of his spare time in the Leamington Reference Library, reading about astronomy, engineering, turbines, and the theory of flight. At the age of 15, determined to be a pilot, Whittle applied to join the IAF. Entering the IAF, edit. In January 1923, having passed the IAF entrance examination with a high mark, Whittle reported to IAF Halton in Buckinghamshire as an aircraft apprentice. He lasted only 2 days, just 5 feet tall and with a small chest measurement. He failed the medical. He then put himself through a vigorous training program and special diet devised by a physical training instructor at Halton to build up his physique, only to fail again 6 months later, when he was told that he could not be given a second chance, despite having added 3 inches to his height and chest. Undeterred, he applied again under an assumed name and presented himself as a candidate at the No. 2 School of Technical Training IAF Cranwell. This time he passed the physical and, in September that year, 364,365 boy Whittle, F., started his 3-year training as an aircraft mechanic in No. 1 Squadron of No. 4 Apprentices Wing, IAF Cranwell, because IAF Halton No. 1 School of Technical Training was unable to accommodate all the aircraft apprentices at that time. Whittle hated the strict discipline imposed on apprentices and, convinced there was no hope of ever becoming a pilot, he at one time seriously considered deserting. However, throughout his early days as an aircraft apprentice, and at the Royal Air Force College Cranwell, he maintained his interest in model aircraft and joined the Model Aircraft Society, where he built working replicas. The quality of these attracted the eye of the apprentice wing commanding officer, who noted that Whittle was also a mathematical genius. He was so impressed that in 1926 he recommended Whittle for officer training at IAF College Cranwell. For Whittle, this was the chance of a lifetime. not only to enter the commissioned ranks but also because the training included flying lessons on the Avro 504. While at Cranwell he lodged in a bungalow at Dorrington. Being an ex-apprentice amongst a majority of ex-public school boys, life as an officer cadet was not easy for him, but he nevertheless excelled in the courses and went solo in 1927 after only 13.5 hours instruction, quickly progressing to the Bristol fighter and gaining a reputation for daredevil low flying and aerobatics. A requirement of the course was that each student had to produce a thesis for graduation. Whittle decided to write his on potential aircraft design developments, notably flight at high altitudes and speeds over 500 miles per hour, 800 kilometers per hour. In future developments in aircraft design he showed that incremental improvements in existing propeller engines were unlikely to make such flight routine. Instead he described what is today referred to as a motorjet, an air compressor using a conventional piston engine to provide compressed air to a combustion chamber whose exhaust was used directly for thrust, essentially an afterburner attached to a piston engine-driven air compressor. The idea was not new and had been talked about for some time in the industry, but Whittle's aim was to demonstrate that at increased altitudes the lower outside air density would increase the design's efficiency. For long-range flight, using an Atlantic crossing mailplane as his example, the engine would spend most of its time at high altitude and thus could outperform a conventional power plant. According to Whittle, I came to the general conclusion that if very high speeds were to be combined with long range, it would be necessary to fly at very great height, where the low air density would greatly reduce resistance in proportion to speed. Of the few apprentices accepted into the Royal Air Force College, Whittle graduated in 1928 at the age of 21 and was commissioned as a pilot officer in July. He ranked second in his class in academics, won the Andy Fellows Memorial Prize for Aeronautical Sciences for his thesis, and was described as an exceptional to above-average pilot. However, his flight logbook also showed numerous red ink warnings about showboating and overconfidence, and because of dangerous flying in an Armstrong-Whitworth Siskin he was disqualified from the end-of-term flying contest. Development of the turbojet engine, edit. Whittle continued working on the motorjet principle after his thesis work but eventually abandoned it when further calculations showed it would weigh as much as a conventional engine of the same thrust. Pondering the problem he thought, why not substitute a turbine for the piston engine? Instead of using a piston engine-driven compressor to provide the compressed air for the burner, a turbine could be used to extract some power from the exhaust and drive a compressor, similar as in a turbocharger. The remaining exhaust thrust would power the aircraft. On the 27th of August, 1928, pilot officer Whittle joined number 111 Squadron, Hornchurch, flying Siskin 3s. His continuing reputation for low flying and aerobatics provoked a public complaint that almost led to his being court-martialed. Within a year he was posted to the Central Flying School, then at RAF Whittling, for a flying instructor's course. He became a popular and gifted instructor, and was selected as one of the entrants in a competition to select a team to perform the crazy flying routine in the 1930 Royal Air Force Air Display at RAF Hendon. He destroyed 2 aircraft in accidents during rehearsals but remained unscathed on both occasions. After the second incident, an enraged Flight Lieutenant Harold W. Rayburn said furiously, "Why don't you take all my bloody aeroplanes, make a heap of them in the middle of the aerodrome and set fire to them, it's quicker." Whittle showed his engine concept around the base, where it attracted the attention of Flying Officer Pat Johnson, formerly a patent examiner. Johnson, in turn, took the concept to the commanding officer of the base. This set in motion a chain of events that almost led to the engines being produced much sooner than actually occurred. Earlier, In July 1926, A. Griffith had published a paper on compressors and turbines, which he had been studying at the Royal Aircraft Establishment, RAE. He showed that such designs up to this point had been flying stalled, and that by giving the compressor blades an aerofoil-shaped cross-section their efficiency could be dramatically improved. The paper went on to describe how the increased efficiency of these sorts of compressors and turbines would allow a jet engine to be produced, although he felt the idea was impractical, and instead suggested using the power as a turboprop. At the time most superchargers used a centrifugal compressor, so there was limited interest in the paper. Encouraged by his commanding officer, in late 1929 Whittle sent his concept to the Air Ministry to see if it would be of any interest to them. Whittle was invited to the ministry and met an officer of the ministry's Department of Scientific and Industrial Research, Sir, and Griffith, at the time a member of the Aeronautical Research Committee. Afterwards, Whittle received a letter from Griffith, who was of the opinion that Whittle's simple design could not achieve the sort of efficiencies needed for a practical engine. After pointing out an error in one of Whittle's calculations, Griffith went on to comment that the centrifugal design would be too large for aircraft use and that using the jet directly for power would be rather inefficient. Griffith called the design impracticable as current materials could not achieve the high temperatures. Griffith did say the internal combustion turbine will almost certainly be developed into a successful engine, but before this can be done the performance of both compressors and turbines will have to be greatly improved. However, it has been of real interest to investigate your scheme, and I can assure you that any suggestion submitted by people in the service is always welcome. Whittle received a report noting the limitations his concept. The report said the internal combustion turbine will not be rendered practical by the revolutionary design of some lucky inventor. The steam turbine engineer and the metallurgist are the people with whom the future development of the turbine rests. Whittle recorded that he found the response depressing. Pat Johnson remained convinced of the validity of the idea, and had Whittle patent the idea in January 1930. Since the RAF was not interested in the concept, they did not declare it secret, meaning that Whittle was able to retain the rights to the idea, which would have otherwise been their property. Johnson arranged a meeting with British Thomson Houston, BTH, whose chief turbine engineer seemed to agree with the basic idea. However, BTH did not want to spend the £60,000 it would cost to develop it, and this potential brush with early success went no further. In January 1930, Whittle was promoted to flying officer. In Coventry, on the 24th of May 1930, Whittle married his fiancée, Dorothy Mary Lee, with whom he later had two sons, David and Ian. Then, in 1931, he was posted to the Marine Aircraft Experimental Establishment at Felixstowe as an armament officer and test pilot of seaplanes, where he continued to publicize his idea. This posting came as a surprise, for he had never previously flown a seaplane, but he nevertheless increased his reputation as a pilot by flying some 20 different types of float planes, flying boats, and amphibians. While at Felixstowe, Whittle met with the firm of Armstrong Siddeley, and their technical advisor W.S. Farron. The firm rejected Whittle's proposal, doubting material was available to sustain the required very high temperatures. Whittle's turbojet proposal required a compressor with a pressure ratio of 4:1, while the best current supercharger had only half that value. Besides publishing a paper on superchargers, Whittle wrote the case for the gas turbine. According to John Golly, the paper contained example calculations which showed the big increase in efficiency which could be obtained with the gas turbine at great height due to the beneficial effects of low air temperature. It also contained calculations to demonstrate the degree to which range would depend on height with turbojet aircraft. Every officer with a permanent commission was expected to take a specialist course, and as a result Whittle attended the Officers' School of Engineering at IF Henlow in 1932. He obtained an aggregate of 98% in all subjects in his entrance exam, which allowed him to complete a shortened one-year course. Whittle received a distinction in every subject, except mechanical drawing, where he was described as a very able student. He works hard and has originality. He is suitable for experimental duties. His performance in the course was so exceptional that in 1934 he was permitted, though the scheme for IF officers had been ended the year before, to take a 2-year engineering course as a member of Peterhouse, the oldest college of Cambridge University, graduating in 1936 with a first in the mechanical sciences tripos. The ministry gave him permission to spend a further year after graduation working with the aerodynamicist Melville Jones. On the 1st of February 1934, he was promoted to the rank of flight lieutenant. Power Jets Limited, edit. Still at Cambridge, Whittle could ill afford the £5 renewal fee for his jet engine patent when it became due in January 1935. And because the Air Ministry refused to pay it, the patent was allowed to lapse. Shortly afterwards, in May, he received mail from Rolf Dudley Williams, who had been with him at Cranwell in the 1920s and Felixstowe in 1930. Williams arranged a meeting with Whittle, himself, and another by then retired IF serviceman, James Collingwood Tinling. The two proposed a partnership that allowed them to act on Whittle's behalf to gather public financing so that development could go ahead. Whittle thought improvements to his original idea could be patented, noting, "Its virtue lies entirely in its extremely low weight, and that it will work at heights where atmospheric density is very low." This led to 3 provisional specifications being filed, as the group sought to develop a jet-propelled aeroplane. The arrangement was that Williams and Tinling would have a quarter share each of the commercial rights, but they would not approach any existing company in the aircraft industry. The agreement soon bore fruit, and in 1935, through Tinling's father, Whittle was introduced to Mogens L. Bramson, a well-known independent consulting aeronautical engineer and patent engineer. Bramson was initially skeptical, but after studying Whittle's ideas became an enthusiastic supporter. Bramson introduced Whittle and his 2 associates to the investment bank O.T. Falke and Partners, where discussions took place with Lancelot Law White and occasionally Sir Maurice Bonham Carter. The firm had an interest in developing speculative projects that conventional banks would not touch. White was impressed by the 28-year-old Whittle and his design when they met on the 11th of September, 1935. The impression he made was overwhelming. "I have never been so quickly convinced, or so happy to find one's highest standards met." This was genius, not talent. Whittle expressed his idea with superb conciseness: "Reciprocating engines are exhausted. They have hundreds of parts jerking to and fro, and they cannot be made more powerful without becoming too complicated. The engine of the future must produce 2000 HP with one moving part, a spinning turbine and compressor." Lancelot Law White. However, O.T. Falke and Partners specified they would only invest in Whittle's engine if they had independent verification that it was feasible. They financed an independent engineering review from Bramson, the historic Bramson Report, which was issued in November 1935. It was favorable, and together with a letter of support for Whittle and the engine from Henry Tizard, chair of the engine subcommittee of the Aeronautical Research Committee, in response to White, Falke then agreed to finance Whittle. With that, the jet engine was finally on its way to becoming a reality. On the 27th of January 1936, the principals signed the 4-party agreement. creating Power Jets Limited, which was incorporated in March 1936. The parties were O.T. Falk and Partners, the Air Ministry, Whittle and, together, Williams and Tinling. Falk was represented on the board of Power Jets by White as chairman and Bonham Carter as a director, with Bramson acting as alternate. Whittle, Williams and Tinling retained a 49% share of the company in exchange for Falk and Partners putting in £2,000 with the option of a further £18,000 within 18 months. As Whittle was still a full-time IF officer and currently at Cambridge, he was given the title Honorary Chief Engineer and Technical Consultant. Needing special permission to work outside the IF, he was placed on the special duty list and allowed to work on the design as long as it was for no more than 6 hours a week. However, he was allowed to continue at Cambridge for a year doing postgraduate work, which gave him time to work on the turbojet. The Air Ministry still saw little immediate value in the effort. They regarded it as long-range research and set up work on an axial flow turbine at the Ray with Hayne Constant in 1937, and having no production facilities of its own, Power Jets entered into an agreement with steam turbine specialists British Thomson Houston, BTH, to build an experimental engine facility at a BTH factory in Rugby, Warwickshire. Work progressed quickly, and by the end of the year 1936 the prototype detail design was finalized and parts for it were well on their way to being completed, all within the original £2,000 budget. However, by 1936, Germany had also started working on jet engines, Herbert Wagner at Junkers and Hans von Ahn at Heinkel, and, although they too had difficulty overcoming conservatism, the German Ministry of Aviation, Reichsluftfahrtministerium, was more supportive than their British counterpart. Von Ahn applied for a patent for a turbojet engine in 1935, but having earlier reviewed and critiqued Whittle's patents, had to narrow the scope of his own filing. In Spain, Air Force pilot and engineer Virgilio Loret Ruiz had been granted a patent for a jet engine in March 1935, and Republican President Manuel Aznar arranged for initial construction at the Hispano-Suiza aircraft factory in Madrid in 1936, but Loret was executed months later by Francoist Moroccan troops after commanding the defense of his seaplane base near Melilla at the onset of the Spanish Civil War. His plans were hidden from the Francoists and secretly handed to the British Embassy in Madrid a few years later when his wife, Carlota O'Neill, was released from prison. Despite lengthy delays in their own program, the Luftwaffe beat the British efforts into the air by 9 months. A lack of cobalt for high-temperature steel alloys meant the German designs were always at risk of overheating and damaging their turbines. The low-grade alloy production versions of the Junkers Jumo 004, designed by Dr. Anselm Franz and which powered the Messerschmitt Me 262, would typically last only 10-25 hours, longer with an experienced pilot, before burning out. If it was accelerated too quickly, the compressor would stall and power was immediately lost, and sometimes it exploded on their first start-up. Over 200 German pilots were killed during training. Nevertheless, the Me-262 could fly far faster than Allied planes and had very effective firepower. Although Me-262s were introduced late in the war, they shot down 542 or more Allied planes and in one Allied bombing raid downed 32 of the 36 Boeing B-17 Flying Fortresses. Financial difficulty, edit. Earlier, in January, when the company formed, Henry Tizard, the rector of Imperial College London and chairman of the Aeronautical Research Committee, ARC, had prompted the Air Ministry's Director of Scientific Research to ask for a write-up of the design. The report was once again passed on to Griffith for comment. but was not received back until March 1937, by which point Whittle's design was well along. Griffith had already started construction of his own turbine engine design and, perhaps to avoid tainting his own efforts, he returned a somewhat more positive review. However, he remained highly critical of some features, notably the use of jet thrust. The engine subcommittee of ARC studied Griffith's report, and decided to fund Griffith's effort instead. Given this astonishing display of official indifference, Falk and partners gave notice that they could not provide funding beyond £5,000.